All right, so today we want to look at piecewise defined functions, and they are exactly what they say. They are functions that are defined in pieces. Now, if you guys ever go to a buffet, do you guys ever eat at buffets?
Yes.
Yes, of course you know you do. If you go, okay, well I'm sorry, don't we? Never mind. If you were to go just down the road here, you'd find CC's, right? Is CC's like one price for everybody? No. If we were to develop a cost function for them, like what does it cost based on your age? So the cost is based on your age, right? It's not based on how big you are, right? What if they said, oh, if you're less than 30 pounds, you eat free, but if you weigh more than 500 pounds, well, they charge you $50. Well, think about it. The odds are going to be within, if you weigh 500 pounds, you're probably going to eat more than someone who weighs 100 pounds.
So wait, someone that weighs less than 30 is like of age?
Could be. But they do it based on age, right? And of course, they use the honor system because we just trust that people are going to be honest about how old kids are. Now, what we have here is a function that is, it depends on how old you are, will determine the cost, right? Yes? Okay, don't look at me like I'm crazy. This is being recorded and everyone's going to know. Maybe I'll tag you in this on YouTube. So here's the thing. The cost is going to be $0 if, and we'll say something like this, if your age is, of course, more than 0, we're not going to have negative age, but less than 5. They usually have something like that, right? You know, kids 4 and under eat free. It's 3 and under.
I used to work there.
Okay, well, fine. Well, this is a better place now. It's 4 and under eat free. And if you're like me, you know that if they turn 5, it's going to be a different price, right? So what I did for my kids is the day before they turned 5, like their birthday was the next day, I went into CC's and they said, how old is he? And I said, he'll be 5 tomorrow. So he still ate for free. Because if I know that if I went in and it's on his birthday, then I'm going to have to pay a different price. So get it the very last day, it's for free. Don't judge me. I'm frugal. Now, and then it goes up to something like $4 if your age is between, say, 5 and, I don't know, let's say 13. And I know, Zach, you're looking like, oh, that's not what it really is. Okay, it doesn't really matter. This is for illustration purposes only. So once your kid turns 5 and then before they become a teenager, it's going to be $4. Does that sound about right?
Is this including the drink?
No, this is not including the drink. Drinks are always extra. And it doesn't matter because the kids are only going to drink water. That's all they need. They don't need sugar. Okay? And then after that, it goes up to something like, $6 unless it's on sale, right? So if the age is greater than or equal to 13. Do y'all agree with me? Now, what we're doing here with these little conditional statements is that we are describing the domain. Remember, the domain is the set of x values that we're using? So what we're saying here is that when you're using x values or a values between 0 and 5, inclusive of 0 but not of 5, then your cost is 0. And you know that if you were to walk in with a 10-year-old kid, how much are you going to pay? You know this, right? It's not magic. You know how to interpret piecewise defined functions in the real world. So if the kid is 10 years old, he falls into this category, which means his cost is going to be $4. And then, if you guys were to walk in there, I think you all are older than 13. I'm giving you the benefit of the doubt there. So you guys are all over 13, so then all of a sudden your price is $6 a person. Does that make sense? It's all based on the age when you go in there. So if I were to go in now, I'm going to have to pay I'm going to have to pay full price for me and my wife, and then my kids are going to be right here at $4 a piece. Although really my younger son could probably pass for someone who's less than 5 years old, but that would be dishonest. And I know you guys are like, I still do it anyways. If they think it's wrong, then whatever. I'm not going to correct them. I'm not going to have morals and ethics. That's stupid. Now, if you were to graph this of course being your cost and this being your A, of course we're saying this is your age, then you have these key breakdowns right here at 5 and 13. Do y'all agree? And so we know that if we were to graph this between 0, let me mark that here for you, between 0 and 5, what's your cost? Your cost is nothing. It's this right here, right? Now, am I including 0? Am I including 5? I'm including 0, but am I including 5? So it's going to remain open, because if we're following along here, the domain for this first segment is from 0 to 5, including 0 but not 5. What happens as soon as you are equal to 5? You jump up here to the $4 level. Do y'all agree? So you jump up here. Let me do this. And so the cost is $4 between 5 and 13. Do I include 5 here?
Yes.
Yes. Do I include 13?
No.
No, because once you hit 13 years old, not only are you even more of a pain in the neck to your parents, but you have to pay more, and you jump up here to the $6 level. Do y'all agree? So I get to include that at 13, and this guy's just going to go on presumably forever. Right? So once you hit that age, you're not going, I mean, maybe I should have a little clause here later on, like once you hit 65, it goes back down to like $5 because you get the senior discount. I know that's one of the things that my dad was looking forward to. He was like, great, now I can get a senior discount on the coffee at McDonald's. I'm like, Dad, you don't drink coffee. He's like, I know, but I can get a discount if I ever drink coffee. But you don't drink coffee. My dad's kind of, well, he doesn't watch these videos, so I can talk about him. It doesn't matter. So if I were to look at this, you see this guy is a function. It doesn't matter where you draw your vertical lines, you're only going to be hitting 1 point every time, right? Even right here, if I draw a vertical line, how many points am I hitting? Just 1, because this guy's closed, but this one is open, so it's just 1 point. So no matter where I draw a vertical line, I do have a function. Are you with me? And you see how it's defined by these 3 different pieces. Yes? So tell me, you've seen something like this before, right? Whether it's at CC's or Golden Corral with the buffets, it's a different price based on your age. Did you used to work at Golden Corral too? No?
I'll stay true to CC.
Word. So you never like went over to Double Dave's? I think I got a really good pizza on the buffet though, the all-meat one. Doesn't matter now because I can't have it. All I can do is dream about it. So sometimes I'll just go in my office and just dream about eating food that I can't have anymore. Like things like donuts and pizza. I can't even talk about it. But there's another piecewise defined function that we do know. Okay? Have you guys ever worked at a job where you get paid by the hour? Yeah, oh wait, CC's is not salaried? So if you work at a job where you get paid by the hour, you might have something like this. Suppose you get paid $12 an hour. I know you're living large if I say that, right? Or is that now the minimum wage? I remember back when I was getting $4.25 an hour, and I thought I was hot stuff when I went from $4.25 to $4.50. I'm like, sweet! That extra quarter an hour, do you know what I can do with it? I can buy an extra pack of baseball cards. Amazing stuff. But here's the thing. This is saying you make $12 an hour, so your pay is going to be $12 times the number of hours you work, right? Is that going to be true for no matter how many hours you work?
No.
Until you get to overtime, right? So there are conditions that need to be met, right? So as long as the number of hours you work is between 0 and 40, now that's inclusive of 40, right? The 40th hour you work is not overtime, is it? No. So as long as you work anywhere between 0 and 40 hours, you could plug it in here and find out how much money you'd make, right? Provided this were accurate of your job. But what about when you do overtime? It's time and a half. So if you make $12 an hour, what's time and a half? It's $18 an hour. So how do you think you would write this as a piecewise defined function? 18x? So you're saying it's 18x if x is more than 40. Is that what you're saying? Now I want you to just imagine with me here. Suppose you work 50 hours, right? Does that mean you take your 50 hours times 18? You only have 10 hours that's overtime, right? So this statement right here is actually not valid. If I say 18x, if x is greater than 40, then we're saying that every hour that I work is at overtime. Well, that's not true. Only what is at the overtime rate? How do you represent the hours at the overtime rate?
41.
It's what?
41.
Well, I'm going to have this as x is greater than 40, but I still have to have an expression that I can plug that x value in here that accurately tells me my pay. So if it's $18 an hour, is it 18 times x? It's not. Well, if we were doing 50 hours, it would just be times 10, right? But what's a variable expression using x that I'd multiply 18 times? Suppose you were to work 50 hours, right? X minus 40. That's the total number of hours you work, right? Minus 40. Why'd you say minus 40, Stephanie?
Because 40 will give you just your regular pay.
Right, so I need to take off the 40 hours at the regular pay, and that will leave me a remainder of whatever it happens to be at the overtime rate. But I have to add back in the hours that I have already worked. So that's going to be $12 an hour at 40 hours, right? So what we're saying here is that if you work more than 40 hours, what's happened? Well, you've worked 40 hours at $12 an hour, but then the excess is going to be at $18 an hour. Does that make sense? And it's still going to be with the condition that x is greater than 40. Okay. Now you can actually graph this on your graphing calculator, even with these conditions. Okay. So I want you to check this out. For this first guy, now you got to be careful how you do this if you're going to use the graphing calculator. Put your expression in parentheses. So you put in parentheses 12x, and then right next to that you would have another set of parentheses and you put your condition. So what I'm really saying here is that I want my x's to be what? Less than 40 for this guy, right? So to do the inequality symbols, you go to test, so you press second, math. So as long as x is less than or equal to 40, it's going to be 12x. The other expression I have is 18 times x minus 40 plus 12 times 40. Make sure you close the parentheses there. And this is going to be for those x values that are what? Greater than 40. Now, if I were to graph this, you are not going to see much of anything. See, watch. There's that guy, and you're not going to see the other one, because my window doesn't make any sense here. My normal window is from negative 10 to 10, so this is kind of stupid right now. Here's what we can do, though. I'm going to go to my window. I'm going to change my setup here. My minimum x should be 0. My maximum, let's say max hours, is going to be 60. Just kind of play around with this. And let's make the x scale to be 5, so every tick mark is going to be worth 5 hours. Now your y scale is going to be for the amount of money that you earn. What's the minimum money that you'll earn? What's the minimum amount that you're going to earn, though? What's the least that you can earn? Nothing. Now the most that you can earn, let's say if you do 12 hours at $40 an hour, how much is that? Excuse me, $12 an hour for 40 hours, how much money is that? It's 480 plus some overtime stuff, so let's make this 700 for the max. And let's make the y scale to be 100. So now when I graph this, watch what happens. Oh, and by the way, if you hit the enter button, that will pause your graphing. You just press it again to continue on. You didn't know that? Oh, and here's another little thing. If your calculator seems to be really thinking hard about something and it's not giving you an answer, press the on button. The on button acts as an interrupt command, so whatever the calculator is doing, it's going to stop, and you will not be able to continue that process. But sometimes it's useful because you may have forgotten a symbol or put something wrong there and maybe caught in an infinite loop or calculating something really large, and you didn't mean to do that. So I'm going to keep graphing here. Now notice, this guy stopped. I didn't stop it there, but it stopped right here. And if you figure this out, that's going to be when x is equal to 40. Now we're waiting for my other line to graph. See how it's starting to pick up right there? Picks up right where I left off, and it's going to keep on going. So you see on this piecewise defined function, this guy ends up being continuous because these guys are connected, right? In the example that I gave about the cost per person at CC's based on the age, it wasn't continuous. It makes those jumps. Okay? So this is kind of neat, right? Look at this. Here's your slope of 12, right? But as soon as you hit overtime, your slope changes to be 18. Isn't that neat? I think it's neat.